Hi everyone. Today I'm going to talk about an implementation of link time optimization without using LLVM's liblto plugin. So the reason for doing this implementation is that even though PlayStation 4 uses a compiler that is based on CLAN LLVM, we have a proprietary linker that does not yet understand LLVM's bitcode format or liblto plugin. On the other hand, game developers demand for every last bit of performance right now. So we want to build some form of LTO so that we can try it out, evaluate its benefits before adding it to the linker. Our implementation, as you will see, is a big detour. So first, we use CLAN to compile each source code to a bitcode file, put those on one side. We save the input libraries and object files for later. And we use LLVM link to combine all these bitcode files into one file. Now we run opt on this combined bitcode file. The next step is to convert this combined bitcode file to a native object file using LLC. And finally, we link this object file with the other object files and libraries that we saved earlier into a final executable. These are a lot of steps. And as you can imagine, it is not easy to integrate all these into any existing build process. And we do not want game developers to have to do these by hand. So what we did is we wrote a Python script to carry out all these steps that we just mentioned, convert that script to an executable using a Py to exe conversion tool. We rename our PS4 linker, replace that with our script. At the compilation step, we pass -flto to CLAN to generate the bitcode files. At the linking step, we just run our script. And everything kind of works. At least that is enough for our experimentation and evaluation. One limitation that we noticed is that opt does not know what symbols are referenced externally. So we need to mark some source code to mark global symbols as attribute used. So we have collected some performance results using the bullet benchmark, comparing LTO build and non-LTO builds at O2. We see a 50% improvement in memory footprint. The text section, the data section, and BSS sections have all seen some improvement. Code size improvement is similar to what we got from linker's dead stripping feature, which is cheaper in terms of build time. We also noticed 5% improvement in runtime performance. We also heard that one major PS4 launch title has tried our implementation and has noticed 10% improvement in code size and 6% improvement in runtime performance. So with the improvement in memory footprint and the runtime performance, we conclude that LTO is definitely worth the trouble to implement. That's it. Thank you.